All right, for this example, we have two cars that are approaching each other on two different roads. Car A, they say, is traveling west at 50 miles an hour, and car B is traveling north at 60 miles an hour. Both of them are headed for the intersection of the two roads. So let's quick draw a sketch of this. We've got one car traveling west and one car traveling north. Car A, this is car A right here, is traveling at a rate of 50 miles an hour. And car B, down here, is traveling at a rate of 60 miles an hour. And what they want us to find is they want to find the rate that the distance between the cars is changing. So that's this, if we think of this as x, y, and z, what they want us to find is dz dt. So the rate between those cars are changing. And they tell us that we want to find this rate, or they ask us to find this rate, oh, too far. Find this rate when car A, so our x distance, is 0.3 miles, and car B, our y distance, is 0.4 miles. And let's use the Pythagorean theorem to figure out what z is before we look at or take the derivative of our function. So if we have x squared plus y squared equals z squared, what we end up finding is that z is 0.5. So that's a 3, 4, 5 right triangle, actually. But let's go back up to our equation. We look like we have, or looks like we have all of our information now. We can use our x squared plus y squared equals z squared equation. Take our derivative right away, and we get 2x dx dt plus 2y dy dt, and that equals 2z dz dt. Looking at our equation here, what we can do is we can cancel out a 2 from each one of these to simplify our equation a little bit. Let me scroll down here. And we end up with x dx dt plus y dy dt equals z dz dt. So at this point, we're going to plug in that information that we know. We know x, y, and z. We know dx dt. We know dy dt. And dz dt is what we're trying to solve for. This is what we're trying to find here. X is 0.3. dx dt, they say it's moving at 50 miles an hour. And we're going to say that it's negative 50 for our rate here because our car is moving closer and closer to that point. So the distance from where our car is at right now to the intersection point is getting less and less. So it's a negative 50 for our speed. Our y is 0.4, and it's the same thing for our dy dt. That direction is in the negative direction because the distance between where the car is to the intersection point is getting smaller and smaller. So we say that dy dt is negative 60. And this equals 0.5 dz dt. Simplifying the left side of our equation here, we end up with negative 15 minus 24 equals 0.5 dz dt. Negative 15 minus 24 is negative 39. And then we can divide by 0.5, which is the same as multiplying by 2. So dz dt is negative 78 miles per hour. So that distance between those two cars is changing. It's getting smaller at 78 miles per hour at the instant where these two cars are 0.3 distance or 0.3 miles away for x and 0.4 miles away for y.